So this was the problem which we were solving in the first part of the roof trusses. The question is here. So the dead load is 120 Newton per meter square and the wind load was 2 kilonewton per meter square, and purlins were spaced at 2 meters center to center, and the trusses were spaced at 4.5 meters center to center, and the pitch was 1 in 4. So the span of the roof truss is 20 meters. So we were solving the channel section, that is the first part. After that we had drawn the channel section here. So this is the sketch, okay, and this is the dead load combination. Okay, so the dead load is 0.2 kilonewton per meter square and UDL due to dead load was 0.12, because we have converted this 120 divided into kilonewtons, hence we have to divide it by 1000 in order to get that. And next it was all about calculation of pitch, okay, and then it was along z axis and y axis. Now when we got down to live load calculation, so we had used the IS 875 part there. Now next we had come down to calculation of wind load along z direction and y direction. Okay, along y direction we found it was 0, and after the load combinations we had finalized WDZ and WDY content, and after that we had come down to this design bending moment in z and y directions. After that we had calculated even bending moment in y direction and shear forces in z and y directions, and trial section we had this formula. Okay, so we have finalized ISMC 222.1 kg per meter. Then we had check for flexure, where we had to follow one of the design equation, and then we had come down to flange and web classifications, then finalized as plastic section. And in order to calculate MDY we had taken this sketch into account. Okay, so that this is the equation for MDY, and now we had taken this sketch into account. So you can have a snapshot of this sketch while you are practicing it. Then you can this was a calculation from where we have finalized the x bar. So this was the x bar here, the calculated part of that. Okay, so after this we had finalized the MDY part. Okay, so we had calculated with this sketch, which so first we started with this portion, then web portion, flange portion, web portion, and then the shaded portion. Okay, we can class this is flange portion, web portion, and shaded portion. So we had finalized from that equation, and then we had gone for check for shear, and then we had done the check for deflection. Okay, now the one part which was left out is design for suctional effect. Okay, what is the suctional effect? We have to understand that. Okay, suctional force is a negative effect of wind load, mainly will be applied to vertical surfaces and also to roof trusses and horizontal surfaces also. It will be acting okay, like in a vacuum that pulls on a building and its components. So there will be two load combinations, out of which you have to select one of the load which is in negative, because the suctional effect is the negative wind load only. So here with the VDZ1 you got the positive wind load with the first load combination, and the second load combination tells you this. So VDZ2 is 0.9 WSWZ minus 1.5 WWZ. Okay, so here you got as minus 5.8 kilonewton per meter. Now hence negative indicates wind pressure giving rise suction effect. Okay, so the hence VDZ is equals to 5.8 kilonewton meter. Hence you have to calculate the bending moment out of this. Okay, hence MDZ is 14.6. New MZ value got with the suctional effect, and MY remains the same, okay, as calculated before. Now in the previous it was like laterally supported, here the compression flange is laterally unsupported because of the suction effect. Okay, it doesn't have any support for the suction effect. So the MDZ formula will change here. Okay, so beta B, ZPZ, and FBD. Now you have to calculate FBD, because we already know beta B is 1 and ZPZ already available, okay, as per the calculated one. For in order to calculate FBD you have two values here. Okay, one is KL by RY and H by TF. If you want to calculate FBD, you need these two values to be calculated. You have the calculation part here. Okay, you got 141.2 as KL by RY and H by TF as 16.5. Now if when you have both these values, now referring to table 14, you will get the critical shear stress. Okay, critical stress you will get as FCRB from page number 57 IS 800 2007. We get FCRB as 235.8 critical stress. Once you get FCRB, you will get FBD 147.1 Newton per mm square by looking into the table. So you have to substitute that value in MDZ formula to get the MDZ, and MDZ is 31.05. Now MDY you have already calculated as 7.1. Now you have to substitute all these values in this equation, okay, in the design equation, in the new design equation, it should be less than equals to 1. So when you substitute it, you will get as 0.71, which is again equals less than 1, hence it is safe. So your purlins with the available loading conditions, it is safe against the suction effect also. Thank you.